Virtual reality, more commonly referred to as VR, is an emerging technology that aims to revolutionize the way that people interact with the online environment. With applications ranging from gaming and entertainment to education and training, VR offers a unique opportunity to create interactive and engaging learning experiences that would be difficult or impossible to replicate in the physical world. Additionally, VR has the potential to connect people from all over the world for collaborative learning and social interaction, offering new opportunities for learning and collaboration that were previously unavailable. Despite being considered an emerging technology, VR has already gained significant interest and support from consumers, and as it continues to develop, it becomes more accessible and can expect to see even more innovative uses for VR in the future. The SAMR model is a teaching framework created by Dr. Ruben Puentedora that shows the impact of different technologies on teaching practices. When considering the SAMR teaching framework, VR fits into both the modification or redefinition stages of the framework. At the modification level, VR can be used significantly to modify the learning experiences of students, creating experiences that were previously impossible. For example, virtually completing a science experiment that would be difficult or dangerous to conduct in a classroom would be considered a modification and a great learning experience for students. In the redefinition stage, VR could also create new learning experiences directly related to real-life scenarios. For example, students could practice how to administer first aid in a medical emergency and be graded on their responses. When successfully using VR in the classroom, there are many factors to consider to ensure it is used effectively. Understanding current multimedia design theories gives important insight as to how VR technology could be successfully implemented in classrooms. Theories such as ADDIE, SAM, and Myers principles of multimedia design all give clear guidelines for its successful implementation and issues to consider. Myers' principle states that people learn better from words and pictures rather than just words alone. Visual cues are powerful for supporting learning, and VR is a perfect tool for this. Through its use of superior graphics, interactive experiences, as well as engaging narration, VR can take students out of the classroom and into interactive environments rich with learning. The ADDIE and SAM models are effective in guiding the design process when creating VR content. Using the ADDIE model's 5 phases, we can use VR effectively to design unique learning experiences for students. Let me take you through how this could work with the ADDIE model. In the analysis phase, the learning objective is identified as well as considering a range of individual students' needs to ensure that the VR content aligns with the desired learning outcomes. The design phase then allows teachers/creators to create and plan content as well as plan teaching strategies based on the learning objectives and individual students' needs. More than one version of the VR content may be required to differentiate for different students. Myers' principles of multimedia design will also aid in enhancing the VR content to have maximum impact. In the development phase, designers create and set the VR content and user interface that aligns with the learning objectives and instructional strategies. Next comes the implementation phase, where designers deliver the VR content to the user using appropriate delivery methods and technology to suit the goals and needs for the students. Seeking feedback and guidance from users throughout its implementation is very important. The final phase is evaluation, where users assess the effectiveness of the VR content and make changes as necessary based on student and teacher feedback and evaluation results. As you can see, implementing VR into a learning environment requires a comprehensive understanding of not only the technology itself, but also consideration of students' needs, their understanding, and their technological capabilities. There is no doubt, however, of the positive impact it could have on education. The quality of this technology is essential for it to be implemented into the education systems. There are many factors to consider, and I'll outline the main ones now. The first consideration is technological affordance. As VR is always improving, it is a cutting-edge technology that will engage students. Improvements in hardware and software, including higher resolution displays, better graphics cards, better sensory tracking, and more, allows VR experiences to become more immersive and interactive for users. The downside of this is that systems will need to be regularly upgraded, and schools will need to keep the technology up to date for students to have the best experiences. Secondly, we must consider the ease of use of the technology. VR is rapidly improving since it was first introduced to consumers, but still has a long way to go in terms of easy and accessible it is for students. The setup required for optimal experiences is a time-consuming and often tedious process. Some people may also experience motion sickness while using VR, but companies have begun to introduce standalone headsets that increase the ease of use significantly by removing tedious setup and decreasing motion sickness issues. As VR technology continues to develop, it will become more and more accessible. The next important consideration is safety. VR is generally a safe technology, but as with any emerging technology, there are some potential risks to consider. Users may experience motion sickness or discomfort while using VR, and prolonged use may lead to eye strain or other physical discomforts. Additionally, there are some concerns about the potential for users to become disoriented or lose their sense of spatial awareness while using the technology, which could lead to accidents or injuries. However, these risks can be minimized through careful design of VR experiences and by ensuring that users are properly educated about its safe use. Privacy is also an important consideration with this technology. VR, like a lot of current technologies, collects data about the people who use it. Therefore, there are obvious concerns to consider surrounding privacy. Information about the user's movements, interactions, or behaviors could potentially be used for advertising purposes. There is also the risk of unauthorized access to user data or data leaks, so it is important for developers to use the best practices for data privacy and security. Schools must be assured that students' privacy is confidential, otherwise they will not invest. There are a few limits as to the implementation of VR, and in education, it could be used in every key learning area. It is an innovative tool to help deliver classroom content in an engaging way. For example, in a science class, VR could be used for virtual laboratory simulations, for experiments that would otherwise not be possible. Immersive field trips could be done through VR to deliver a safe, cost-effective, and unique experience for students. Excursions such as trips into a volcano or the bottom of the ocean or rainforest ecosystems could all be made possible thanks to VR. It can also be used to encourage collaborative learning as students work together on complex projects via the VR learning platform. 21st century learners must be given the opportunity to use modern technology to take their learning to new heights. VR is an engaging resource that can revolutionize the way students grapple with the curriculum content. The technology is always improving at a rapid rate with huge improvements in affordability, quality, and accessibility. There is no doubt that VR can help students experience education rather than simply reading it from a textbook.